Today we're going to talk about acceleration, both conceptually and mathematically. Acceleration is the rate at which velocity changes over time. Just like velocity and speed are the change in displacement or distance over time, acceleration is the change in velocity. It's how quickly an object speeds up or slows down. The unit of acceleration is meters per second squared. We'll talk about where this unit comes from in a moment. This is a vector quantity, so we know that the direction or sign of acceleration points where the velocity is or was the greatest, meaning that if an object is speeding up, it's pointing where the object's going. If an object is slowing down, acceleration is pointing away from where the object's going. The unit of acceleration comes from a velocity first time graph, the slope of a velocity first time graph. For every second, the velocity, which is meters per second, changes. So we know that the slope can be found rise over run when it comes to units. The rise would be meters per second, and the run would be seconds. So we'd be taking meters per second divided by seconds. If we take a quick moment and think about math, instead of dividing by seconds, we can multiply by the inverse of second, or 1 over seconds. Meters times 1 gives us meters. Seconds times seconds gives us seconds squared. This is how we derive the unit, meters per second squared. When we describe motion, we need to think in terms of direction and the type of motion or type of acceleration. In this case, we have direction, which can be forward or up. That'll be a positive direction. Remember, we're dealing with only one dimension right now, so we only have up or down. Backwards or down would be negative. So a scenario could go forward, which would be positive, up, which would be positive, or backwards, which would be negative, or down, which would be negative. Velocity can change in different ways. So there's 3 different types of acceleration that we can deal with. We can have an object speed up, we can have an object slow down, or we can have an object change directions. To highlight that concept, let's imagine a baseball. A baseball thrown in the air is going to, by the end, go through all 3 different forms of acceleration. Due to gravity, the ball is always going to be accelerating downward towards the earth. So on the way up, acceleration is pointing down because it's slowing down on the way up. It hits the top, changes directions, and then speeds up on the way down. So acceleration is always pulling down, but when acceleration is in the same direction as the motion, we get a positive acceleration. Let's explore that a little bit more with a car. The direction and sign of acceleration always points in the direction of higher velocities, meaning that if a car is speeding up forward, all of the faster velocities are forward. Rather, if it's slowing down forward, all of the slower velocities are ahead of it. If acceleration and velocity are pointed in the same direction, the object is speeding up. Remember, acceleration and velocity both are vector values, so they have direction. If they're going in the same direction, the object's speeding up. If the acceleration and velocity are pointed in opposite directions, the object's slowing down. Let's look at our first car. This car has a positive acceleration and a positive velocity. Because of that, it's speeding up. This next car is coming to a stop. Its acceleration is pointing backwards. It was going faster to the left, but its direction, its velocity, is forward. The next car, it's going to go backwards, and it's going to speed up. All of its fastest velocities are to the left, and it's going in that same direction, so it's speeding up. The last car is coming to a stop. It's moving backwards, but all of its fastest velocities are ahead of it. So, because velocity and acceleration are pointing opposite directions, this car is coming to a stop or slowing down. If you already know whether an object is speeding up or slowing down, and you know the direction of its velocity, you can calculate the sign of the acceleration using similar rules to those that we use to find the sign for a multiplication problem. Opposite sides multiply together with negative. The same signs multiply together with positive. Multiply the sign of the direction by the sign of the change of velocity. So, for example, an object is speeding up backwards. Speeding up is positive. Backwards is in a negative direction. Positive times negative gives me a negative acceleration. An object slowing down backwards. Slowing down is a negative change, and backwards is a negative direction. This gives us a positive acceleration. Acceleration is not as cut and dry as velocity. Velocity is positive and it's forward. Negative means backwards. When we have to do an acceleration, we have to look at what the velocity is doing. Is it speeding up, is it slowing down, and the direction. Do not assume that a positive acceleration means speeding up, or that a negative acceleration means slowing down.